In this video, we will be going over true economic value. So we're going to learn how to price a product based on objective economic value. So true economic value, TEV, that stands for true economic value. Another way to interpret this true economic value is the maximum price that a company can charge to its customers without losing them to its competitors. So again, another way to define true economic value is the maximum price that a company can charge to its customers without losing them to its competitors. So in this definition, there's a subtle word that should stand out. That's very important. It's very subtle. And can you think of what that word would be in this definition that I just told you? It's the word can. In other words, the company can charge, which means that it doesn't have to charge, but it can if it wants to. Typically, in practice, companies do not charge this. So this is kind of like a theoretical ceiling price that they have in mind when they go into negotiations. So if they charge above this price, then most likely customers will switch to a competitor because they will perceive that it is too much. So that's why they can charge this, but typically in practice, they do not. So in formula, TEV can be written as the price of the next best alternative product plus the value of performance differential between my product, the focal brand, and the next best alternative product. So in formula, it would be written in symbols. It would be written as where the subscripts A represent the focal brand, in other words, my brand, and B would be the next best alternative product. TEVA, so the maximum price that brand A can charge to its customers, would be equivalent to the price of B, right? The price of B, which is the price of the next best alternative product brand, plus the differential in value between my brand and which is A and the next best alternative brand, which is B. So that's VA minus VB. So again, that's PB plus VA minus VB. VA minus VB, the difference between the two brands in terms of value, that's delta V, right? Because delta means change, the difference. Okay, so again, that's TEVA equals PB plus VA minus VB. Now let's dissect this in greater detail in the next slide. So in this next slide, if we decompose this a little bit further, we can think of three different scenarios where VA minus VB can be either zero, right? That could be the difference between A and B in terms of value can be zero. It could be greater than zero, in other words, it's positive, or it could be less than zero, which in this case, then it would be negative. So let's take a look at when it's zero. So if VA minus VB is zero, that means that the two brands, A and B, are providing equivalent amounts of value to customers, right? I mean, there's no difference in the amount of value that my brand, A, is providing to customers than brand B, which is the next best alternative product. So if that's the case, then the maximum price that brand A can charge to its customers, TEVA, should be equal to the price of B, right? Because if I'm not providing any more value than the next best alternative product, what gives me the right to charge more than the price of B? You may be able to charge more in the short term. You may be able to get away with it for a short duration, but eventually over time, customers will figure out, they'll find out, and they'll be discontent and they'll be dissatisfied, and eventually they will most likely switch. So that's scenario A. Moving on to scenario B, when VA minus VB is greater than zero, right, that means that I am providing more value than brand B. That's a good thing from my perspective, from brand A's perspective. Therefore, the TEVA should be greater than the price of B. Why? Because I am providing more value than brand B. So my price should reflect that. It should be captured in the price that I'm charging to my customers. So that's why we see TEVA is greater than PB. But then the question becomes, how much more should I charge than the price of B? Well, you should be able to charge VA minus VB more, that much more, right? Because that's the difference in value that I'm providing compared to the competition, right? Compared to brand B. Therefore, I should be able to charge more than the price of B by that much more. In other words, VA minus VB more. So that's scenario B. Moving on to now the last scenario, C. If VA minus VB is less than 0, then this is the opposite of scenario B, where I am providing less value than brand B. So if I am providing less value than brand B, then I should charge a lower price than brand B. That's why we have TEVA is less than PB. But then again, the question becomes, how much less? Well, it should be by the differential in value, that much less. In other words, by VA minus VB less. Right? So again, to recap, the TEVA is equal to PB plus VA minus VB. And we can think of the three different scenarios where the differential in value between A and B is equal to 0, greater than 0, or less than 0. And depending on which scenario you're in, the maximum price that you should be able to charge, or you can charge, I should say, you can charge, will be slightly different. And typically it will be different by the differential in value, in which case it would be VA minus VB. So in the next two slides, let's take a look at an example to make this a little bit clearer. So an example of true economic value. So let's say that we have a toy manufacturer, and so this is a company that builds toys, and it's considering buying an air filtration system to install in its factories where it manufactures its toys. And it's trying to decide, and then we have this air filtration system seller, which is trying to sell its products to this toy manufacturer. And if you look at this table here, we have two columns, the reference and new. So reference means this is the existing, there's an existing air filtration product in the market currently. Okay, so this is like the incumbent product that's currently being sold in the market. And then new is the new product, the new air filtration system that this company is trying to sell to the toy manufacturer. So we have a couple of assumptions here. We have some data here. Let me just go over quickly what some of the data, the numbers in this table. So the operating cost per hour is $10 for the reference. It's $15 for the new. The probability of system crash, so the probability of this air filtration system crashing, is 20% over a year for this reference product, for the existing product in the market, whereas for this new product, it's only 1%. And in the case that the system does crash, the cost, right? So if the system crashes, then there's going to be a lot of cost involved because they can't manufacture the toys. So the cost of the system crash for the reference product and for the new product is $100,000. They're equivalent. And then the hours of operation also, they're equivalent at 2,500 hours. And the reference price in the market currently is $75,000. And we're trying to determine the price of this new air filtration system that should be charged this toy manufacturer. Okay, so based on this data that we have in this table, and based on the formula that we just learned in the previous two slides, TEV of this new product, TEV of this new air filtration system, should be the price of this reference product plus the differential in value that this new air filtration system is able to provide to this toy manufacturer compared to this reference product that's being sold in the market currently. So which is then the system crash savings minus the added operating cost. So if that's the word equation, the equation written in words, if we plug in the numbers then that correspond to this word equation based on this table, then the price of the reference is $75,000, right? That's what's shown in the table. And then the system crash savings would be, because the system crash for the reference product is at 20%, whereas for the new product, it's only at 1%. So the system crash savings would be 20%, which is 0.2 times 100,000 minus 1%, 0.01 times 100,000. So that's the system crash savings. And then the added operating cost would be 2,500 hours, right, times 15 hours. So you're using more, the operating cost on an hourly basis is more expensive for the new product as compared to the reference product. So it'd be 2,500 times 15 hours minus 2,500 times 10 hours, right? So that would be the added, that would be the incremental operating cost that the toy manufacturer would have to incur by using the new product, the new air filtration system, compared to the reference product. So then if you do the calculations, it would be $75,000 plus the $19,000, right? That's the system crash savings, right? That would be the savings that you would realize, that you would experience if you use the new air filtration system as opposed to the reference air filtration system, minus the $12,500. So that would be the added operating cost. So in net, you would be saving what? 19,000 minus 12,500. That's 6,500, right? So that would be the differential in value. So although you are incurring more operating costs, incremental operating costs, you are saving much more in system crash savings. So in the end, it turns out the net turns out to be positive of 6,500. So then you add that 6,500 to the 75,000, which gives you then 81,500. So this is the maximum price that this air filtration system company can charge to this toy manufacturer for its new air filtration system. In other words, they don't have to charge this, but this is the price that the supplier or the seller would like to charge to the buyer. So this is the price, 81,500 from the seller's perspective. But in the next slide, we see that the numbers change a little bit in this table. So all the numbers in this table are exactly the same as numbers that you've just seen in the previous table on the previous slide, except for one number, which is if you look at the new column, the new product column, instead of the probability of system crash being 1%, now it's 5%. So what does this mean? This means that the toy manufacturer will say, hey, wait a minute. I mean, we think that what the seller is claiming, the 1% probability of system crash, is unrealistic. They think that it's too low. So they think that a more realistic probability of crashing is at 5% and not at 1%. So this is the perceived value that the toy manufacturer believes in. So if nothing else changes, but only the probability of system crash from 1% to 5%, then going now, if you look at the equation, the perceived value then will be 75,000 plus 0.2. Again, that's 20% times 100,000 minus, instead of the 1%, it's 5%, so it's 0.05 times 100,000, right? So that's the only thing that really changes. Everything else, the 2,500 times $15 per hour minus 2,500 hours times $10 an hour, that's intact, right? That's the same. So then it's 75,000 plus 15,000 minus 12,500. So you see that the only thing that changes here is the 15,000, right? So in the previous slide, I think it was 19,000. Here it's 15,000. So it's been downgraded. Why? Because the buyer, the toy manufacturer, does not believe that the 1% of probability of system crashing is realistic. Therefore, they've increased the probability for 1% to 5%, which then lowers the system crash savings from 19,000 to 15,000, which then, if you subtract 15,000 minus, if you do that calculation, if you take away 12,500 from 15,000, that gives you 2,500. And if you add that to the 75,000, then the price that you end up is 77,500. So as you can see, from 81,500 to 77,500. So it's been lowered. In other words, this is the price that the buyer, the toy manufacturer, is comfortable in, because this is the value that they believe in. Right? So the 81,500 is the value, is the price that the air filtration system company, the seller, would like to charge based on how much they believe their product is worth, right? Based on true economic value or objective value. But this is the 77,500 is the price that the buyer, the toy manufacturer, believes in. In other words, this is the perceived value, right? This is how much they believe the air filtration system is worth, and hence this is the price that the buyer will most likely be willing to pay based on how much value they perceive from the product.